Bom dia para todo mundo, pessoal. A gente vai começar um Meetup hoje com nosso amigo Gerard. Obrigado a todo mundo que entrou, tanto do CESAR quanto o pessoal do Porto Digital, do nosso ecossistema. E Gerard é um amigo da gente, né? Trabalhou no CESAR durante muito tempo, é meio recifense, meio holandês. E está de volta na Holanda há um tempo, mas a gente estava conversando um bocado sobre esse tema que ele está trabalhando na. Tem a ver com o que ele faz no dia a dia de trabalho dele hoje, mas ideias que ele tem de futuro também, e a gente achou que seria interessante compartilhar esse conhecimento com todo mundo. Flavinha quer comentar alguma coisa, Flavinha?
Now, I don't know if there is someone in the event that only speak English. So thank you, Gerard, for coming and sharing the content with us. We appreciate a lot. Let's get started because I believe there is a lot to learn here.
Yes, we are going to record the meeting, okay, just to share with everyone later and share with people that is not available. So as you notice, Gerard is going to do the presentation in English, okay? My friend Gerard, go for it.
All right. Thanks very much. Yeah. So for those who don't know me, Gab already said it. I used to work at CESAR 2004, 2007, but I've also gone back to the Netherlands after that and worked in data engineering. And now I work at Datavault, which is a US startup for quite some time, also in data. And I think it was about last year we completely shifted our company from what we were doing and working on in data towards AI. The whole company just did a pivot basically towards AI engineering, and we are focusing on data migrations by translating the SQL and so on that runs on Redshift to other systems. And in that process, we learned a lot about AI. In the beginning, we were basically struggling a lot to get these translations done. And then sometime, I think it was in October, we suddenly saw this enormous leap in successful translations. And then you start to pay attention and then you recognize that everything has really changed a lot. So one of the things that we noticed also is that it is very easy to not do the right thing and you get some bad results. And what this presentation is about is basically context engineering, which is only now one part, I would say maybe 20% of it, just because how fast this technology is going. I would say actually that if you have not started with AI, this is an urgency for you because I believe that by the end of this year, if you do not work on AI, your job is going to be severely restricted on the job market. You won't be find any software engineering jobs anymore. It is going that fast. So basically, what we can focus on here is that let's say that you have a question that you want to ask to an AI. A lot of people have this sense of AI being some kind of magical oracle, but that is far from the truth. Basically, you're not going to extract anything useful out of the AI unless you put it in. And that is why context engineering is such a very relevant thing, because if it doesn't have visibility of that thing you're asking questions about, it's going to fantasize and hallucinate everything. And therefore, the output that you're going to get is going to be, quite bad. And that is a constant question that you have to ask yourself, what is the kind of things that this AI is reading? What does it have access to? And that will basically limit the usability of the responses that you get. So here we have support engineers and we have engineers, for example. They have different questions. You will notice that the AI is starting to ramble or fantasize, or it's creating a fix that is not really relevant or not in line with the way how it should be done. And therefore you start correcting a lot of it. And that is basically a problem of not loading the right context into the AI itself. So the core idea is basically you have a context window, that is the amount of text that you feed to the AI that needs to have the source of the problem. You need to give it tools, you need to give it some kind of information to know what it can use in order to move forward. And that is the biggest leap that we saw, is that the exploration ability of the AI has surged since October sometime. And that means that it doesn't just have to dig into the visibility of the text in order to find the answer, and maybe its memory, what it has been trained on, but it can actually explore your environment, AWS or your Kubernetes or your code base, in order to find the right information for you. And that is the biggest powerful leap that we have seen so far. So it is not good to have too much context, because then you confuse it, because you give it too much information, and then the efficiency of the response is also reducing. But if you give it too little, then it's also not good either. And here they found through some research that if you give it too much information, like more than 32K, like your entire code base, and then ask it a question, it doesn't necessarily know very well how to answer that question appropriately. So more is not always better. You need to always try to make it exact on what it needs to give you the right answer. And then you just make stuff available to the AI to explore, to read other things, and then it will usually come up with a pretty good answer. So the whole idea is basically, if you ask someone, you have a desk, and the desk is clean and you need to find something, then it's pretty easy to find exactly what you need. But if everything is cluttered and you have a lot of stuff on the desk, it will take you a lot more time to find it, and you will pick the wrong folder, 20 times before you get what you need. And that is basically a similar kind of metaphor, comparison of it. So basically, the anti-patterns that I will explain here specifically to context engineering are these 6. And then let's go through each one of those. So that is basically context overload, which is what we were talking about. The context overload is you put all the stuff in there that you have, all your standards, all your code base, service files, meeting minutes from everything in the past. And then you ask questions about it. And then what it comes up with is that it finds the wrong thing to latch into, basically. And the answer that you get is going to be quite poor. So, if you want to get real homing to the bug, you need to figure out what is the kind of things that is relevant for this particular context where we need to solve this problem. And another thing that we have is context poisoning. So basically, what this means is that the AI can get a little bit sidetracked in certain cases, right? And this sidetracking means that if it makes a wrong assumption and you do not fix it, it will use that assumption going forward. And then it is going to be very difficult for that AI to find the right fix for it. So for example, if you have a comment in the code base that says the real try logic takes up to 3 attempts, but the actual code is taking 5 attempts, then the AI can get a little bit sidetracked on it. It makes the wrong assumption, and therefore the answer that you have is going to be wrong. And this is related to making sure that whatever the AI is going to read from your code base, from your documents, from your design, from your code comments, it has to be correct and accurate, because otherwise you're basically poisoning your context and you give it untrue information, and then it doesn't find the problem, the solution to your problem. And this is the same also what we talked about, enabling all the tools. So MCP servers and tools, a lot of them are relevant to do a whole range of different things for the AI. So for example, if you have Kubernetes, then you want to give it access to Kubernetes, maybe to the test environment. If you have a tool for figuring out some other metadata information that you have behind an MCP server, or you have tools that do other things, then you don't want to activate all of them at once. You will need to activate only the tools that are relevant for working on that particular use case in that flow. But if you have tools for debugging, you want to disable those if you are working on the requirements engineering, for example. So that will also help, because they did some research on it. They had 46 tools active, and it failed to find the real problem. That was on Berkeley research. And then when they reduced that, it was a lot more successful in finding that. And this is also the context clash, which is a different way of doing this. This is now actually being worked on a lot. It is the whole idea that you start to, hey, can you fix this bug for me? And then you don't give it all the constraints up front. And it will make some progress, it will go forward. And you say, oh, but it also has to work in that particular context. And this is also relevant. And the context clash happens when it starts to make progress towards a problem and maybe finding the right solution for that particular context, but without all the constraints. And if you move forward to that, it will find an inefficient problem. It will get stuck somewhere in a particular location where it cannot deal with all the contradictions, because if you steer it away from some particular progress it was making, you're actually, changing direction by quite a bit. You want to do this all the way up front, and that is when you see nowadays people are using planning mode for doing the work upfront. In the planning mode, it just does a scan to figure out how do I successfully resolve this task. It will then figure out everything that is relevant. From there, it splits that into subtasks, and at some point, it comes back with a much better solution. And your ability to modify the plan will allow you to put the constraints in before it starts the actual work. Another thing that is considered also stale documentation, we talked about this before. You have changes in the source code that are not aligned with your comments. That's also a part of basically context poisoning. That is how that could pick it up. Nowadays, when we are dealing with our source code, we pay attention to the comments and we allow the AI itself to actually fix those or eliminate those if they're no longer relevant, because there's a lot of comments that are put in place that you can read from the code itself, and therefore you shouldn't have them in the first place. It should only be there when it is relevant. And that's a basic coding standard guideline as well. And the rest is the exploration waste. So the whole idea is that if you do not structure what this AI has access to, so you give it access to the whole code base and it has to explore it in order to discover what is there, then when you ask the AI, what have you read and what have you found, it will have read a lot of information that has started to accumulate in the context. And therefore, a lot of that is noise that it basically has to eliminate when it is trying to solve this problem. That's why it is important to give it some sense of direction in your code base by creating a hierarchical description of where things are located, so it can quickly navigate it and not even look at the parts of the code base that are not necessary, or other kind of context paths where things might be located. So the best way to do that is that if you want to make good progress, you need to really think about the context, how you're going to engineer your question. You need to think about what does it need access to in order to solve this problem. I'm going to mention it by itself. I'm going to think about other things that it might need access to. I know that, for example, somewhere on the internet, there is some information located about this particular design pattern. And that is the reason is because every time you start a session on the AI, it has no memory. So it is as if you have a very knowledgeable developer that has access to a lot of information to learn from it, but it doesn't know the exact context in which you are asking this question. And the problem sometimes is that people say, well, I talked to Claude a lot before, so therefore it should know it. It just erases all that memory, of course. And therefore it is relevant to every time when you start a new session that you need to understand what is going to be automatically discovered and what are very specific elements that you do not have in your knowledge base that the AI will need to have access to in order to answer these problems. And basically, there are a couple of habits that we need to think about in that sense, right? It is your responsibility to think about the context. With a much better context, the responses that you get from AI are a lot more relevant. You control the desk in that one. Everything that you do upfront is much better than working through it incrementally. So you do planning, and if you want to do some more work before that, you can do some pre-planning for it so that you know exactly how you can basically break down the work that is upcoming, and that you don't have an expectation that you're going to be migrating your entire code base in a single session, for example. And if you see that things are going bad, start over with bad context that you had there, because nowadays when we look, for example, at more advanced usage in it, it will take you a longer time to fix what is wrong than just start over again, fix your context, and then try again. And that is what we're doing, for example, in some of the recent developments that we have started, which is a spec-driven development, where the agents are chatting so much between them that you do not have access to all the sub-agents to tell them what they where they made the wrong assumptions. So what I told you is basically it sounds as if you have to do a lot of manual work every time. Every time you start a new session, do you have to explain how to get to Kubernetes, how to that I have an AWS CLI tool available, other things like that. That is not true. So context engineering is basically controlling what is in the context, but then what is up to you again is about knowledge engineering, and this is where things become different. Before we just had to worry about the code base, the unit tests, and documentation for other humans, and it might be a little bit out of date and it might be contradicting. But nowadays we have to think about knowledge engineering, which we need to be more strategic because we cannot allow for errors in there because it will cause a slowdown in our process for getting our work done. So what we are now need to think about with the old definition of done, that your code works and the tests pass and a couple of other things that we have determined, now we need to ask a question that AI can use it correctly, because if you don't put time into it to make it work, you're going to be doing context engineering very heavily every time you work on a particular problem, and that slows you down. You're not going to get the same velocity that people have promised with AI that you're actually going for. So you have to think about the documentation, you have to think about code comments, everything. So anything that AI will read in your project, you own it. It should be correct. It should be relevant. It should not be too much. It should be appropriate for the kind of problems that you're solving in that code base in terms of size, in terms of depth of information, no duplication, stuff like that. So basically what we're looking at is knowledge engineering. Here I'm also showing a particular repository where I found this from as a relatively good example. What we started doing at Datafold already 2 months ago was to put these things in place. These are basically files that you can put into a directory in your code repository, where Claude and these files give you very specific information about the project. So architectural deviations, language-specific rules, code domain conventions, right? Code rules, stuff like that. We also have commands that we are allowed to use or able to use. And these commands, they give extra capabilities that are very fast into working with your code base. So for example, you can put some common used Git commands in there, and then you can also specify in that command use this only if this in this state, and verify that that is the case. So it is not a command that will automatically run like a shell command. It is a command that has that is going to be run within the context with sensitivity towards the how to say that context that you give in the usage of that command. So that's what makes them really powerful. And then there are certain things that you can put in place also after Cloud Code has done something. For example, it has created a new document file. You can make a hook that after its reasoning, you're going to check on the documents that it created to make sure there is no duplication, to make sure of formatting, linting, and other things. So when we have code files being modified, we automatically lint and format them right after the fact, so that we don't need git commits anymore. And this will allow also the agent itself to use them effectively instead of trying to do it itself, because it is much better if that is done by a tool that's deterministic, and an agent by itself is non-deterministic, and therefore you might get deviations in the actual output. Well, there's also skills that we are giving it for capabilities, and those skills are more like reasoning skills. So for example, spec-driven development is an agent skill. What it means is that you can start a particular workflow by the agent that will ask questions about what the requirements for a new feature that you're planning. And then through the interaction where you ask questions and where the skill is asking you a question, it will formulate everything that you say in using a particular template into a requirements document. That requirements document then becomes the source for the planning for other specialized agents that are going to do the planning itself. And then there's, of course, we talked about toolings and multi-agent workflows and usage monitoring and other things. The workflows and guides, they are giving some interesting tribal knowledge into, playbooks and other things that might be relevant to how humans, for example, are also interacting with the code base. So here's something that is interesting. Before we had basically a model and we had the context, and that was more like a one-shot LLM activity. If you have used AI for the last time about 6 months ago, that is where we were at. Here is a particular context. You have learned something and have had exposure to something that you now have retained in your memory, although it is a little bit fuzzy. And therefore, when you ask the question, you get what the agent has currently access to, its retained information, and then it will produce a particular output of a particular type. And that has not been very useful because you could basically ask it to produce functions, but not beyond that. And nowadays, what we have is the context with the knowledge repo feeding more context into that when it needs it. The agent does that by exploration in your code base. The models that we have had, they have gone from Sonnet 3.5, it was relatively okay, to 4.5, and now Opus 4.6. They are working quite differently, and also the way how Cloud Code, for example, is using them is that it has made them recursive. And recursive means that instead of having a one-shot output for an AI, it is using internal reasoning to figure out other things, doing exploring, finding out more, questioning what it learned before. Is it correct? And that is like a whole recursive process that can actually involve not necessarily one single agent, but a team, like a swarm of agents that are working together and chatting, where one agent looking at security, another one looking at some other kind of topic, are discussing together as if you would have an engineers in a meeting room that are talking about the implementation of a feature from a particular perspective. And then the joint expertise of all those agents that are forced to only look at the problem from that perspective will give you a solution that is much better refined than if a single agent would have to do it with all the knowledge repo. And that is why sub-agents and this distribution of tasks is a very important element in the use of AI going towards the future. You will see it more and more. And then what you will get is basically higher output quality. So instead of a one-shot, maybe fantasized thing where it made a lot of assumptions, you get a very well explored understanding and answer that has looked at all different perspectives of software development. So here is a picture of basically when you think about software engineering going all the way back and how that has influenced the different things. The relevance of it is basically to understand where we are coming from in software development and what was relevant at that particular time. So we have, the waterfall, and we had object orientation, and they're bringing in new kind of development methods and methodologies like Agile, for example. And at some point, go ahead. All right. And then TDD. Walter, do you have a question? Oh, okay. TDD and BDD, for example, they're coming from continuous integration. And at some point, you see the AI co-pilots starting from the 2020s, where it started with just designing or improving functions and fixing code comments towards completely spec-driven development that is going towards the future. There, we are not writing code anymore as humans, but we are telling AI how to write, not how to write the code. We're telling AI to write code that fixes particular problems. And that is a huge leap going forward because the velocity that is there, it is not, somebody described it best as hyperbolic, meaning that it is not even exponential, it is just going almost unlimited. If I now look at GitHub and you look at those pictures about the number of PRs and the number of commits being generated, they see a huge spike starting around end of 2025 and beginning 2026. So already people are philosophizing about where this goes towards the future. And they started to use this term called dark software factory. A dark factory in China is a factory where they're producing cars, but they're not doing that with humans anymore. Their lights do not need to be on, therefore the factory is dark. They only have a couple of humans going through it to check on the machines and different things and maybe doing maintenance on the machines, but they're not participating in the process of manufacturing cars anymore directly as a human being part in the assembly line. And in a way, what you think about it, this is also where we are going with AI in the end. And it might surprise you, but I think that there will be a number of companies by the end of this year that would probably be level 4, maybe 1 or 2 will be level 5 already. We are currently at the moment, I would say, working on level 3, trying to get to level 4, where we see a number of challenges coming up, especially on the part of where you have to think about overarching elements when code is being modified. So, for example, it is quite easy for an AI now to produce lots of code and solve the problem, and it will fix it. But there are different parts in this where it is basically able to cheat, and it doesn't necessarily have a very good understanding of what good design is and what a good architecture looks like. So what we are struggling with is basically to explain what that would be. And as soon as we fix that and we have an agent that understands good design and architecture, basically you can just let it go. We will be able to auto approve all the PRs that people are making from AIs, not from human reviewers. And that will basically mean that there will be a massive velocity gain for the entire company, because a lot of the time people that are unable to make progress is because other human reviewers are not available to review the PRs. So the key points that I wanted to specify here, that this is about context engineering. So you need to be really selective what you put in the context. You need to understand what goes in there. The desk is based on your GitHub repository or the resources that you give it access to with your tools. You need to organize that knowledge. It's not just about tests, not about the code anymore. If the AI has access to it, in order to be able to read it, you own that kind of knowledge. It has to be also correct. And I'm also noticing that the software engineering role that we have right now is changing extremely fast. What I'm talking about right now already, I think in about 3 weeks, 4 weeks time, we will already be doing things slightly differently going forward. And I see a number of messages here and there where people are from those AI companies are saying that pretty big changes are coming up as well. So that is my presentation. Thanks very much. And then what I would like to do is see if we're going to do questions, Gab.
Yeah, that's the idea. Thank you very much, Gerard. There were some questions here, Gerard, that I'm just going to repeat to you. Guys, if anyone wants... Vou falar em português, tá bom? Se alguém quiser fazer a pergunta em português, pode fazer, que Gerard entende de boa, tá bom? Ele só vai responder em inglês, porque acho que vai ser mais fácil para ele. Não tem problema. Tem uma pergunta que, acho que uma primeira que Perazzo tinha feito, Gerard. Does code-based indexing helps with the exploration case, so we don't need to point to specific relevant files for the context?
Yeah, so what we do with code-based indexing, it's just having a little bit of a directory. So for example, you need to think about how you organize this index. If you say, for example, if you're looking for API files, they would be in /source/API v1, for example. That is enough for in the root document. So the root document describes where things are located, unit tests are here, code is there, and so on. And then in the source directory, you can then specify further, API code is over here, middleware code is over there, authentication code is over there, and that will really help it to narrow down where it needs to look, because otherwise what Claude Code will do, it will grab a lot of the code, right? So it would do some figuring out where all the code files are located, and then it will grab for authentication kind of related stuff, and eventually it finds it that way. But the index is going to make it a lot easier to find it. And also there is a lot of cases where I see that it doesn't find it, and then it will try to fix the problem without having all the code files available. So then you miss the client-side updates of the client code, the user interface, and then it will only have the backend changes, but not the user interface changes. Yeah, I can make the slides available.
José Vitor, acho que levantou a mão primeiro, depois Pedro.
So, good morning, Gerard. I have
Hi.
some doubts regarding agentic AI. I've seen a lot about knowledge engineering targeted towards agentic AI development. However, many code bases nowadays are not allowed to integrate with agentic AI. So I would like to ask you if you know any good indications or guidelines for when we cannot integrate agentic engineering into our code base, but rather we still want to improve our context engineering process without necessarily integrating a LLM agents into our code base. So if you would know some good strategies or guidelines for that scenario.
Yeah, maybe there's a little bit of confusion. So I'm not talking about integrating agents in your code, so in your product, but I'm talking about the use of agents from your desktop. and that is from Claude Code, for example, or Cursor, for example. So you use an IDE or a local development tool, and that tool is going to be able to read through all those documents and solve those problems. Obviously, if you're not able to use agents, then it will be a little bit more difficult to find, what would be the value of organizing it, because then you're basically working with other humans, and then that would not be so relevant in that case. Is that a good answer?
Yeah. I understand now. I was imagining some sort of agent integrated into our remote code base before.
It is possible we have it. Before I did this, I was actually using remote agents that have more thinking time. They spend 10 to 20 minutes on it. And that would be like a SaaS solution that from that SaaS server, it would access the code base. But this is mostly targeted at using Claude Code locally or Cursor locally, where of course you do have a remote connection to some SaaS inference AI.
Sure. Thank you. Thank you for the answer.
O próximo na lista é Pedro, depois tem Yasmin.
So my question, thank you first for your presentation, was very clarifying. So first of all, given a context here, I'm working with my team in a design system project. So basically there are several instructions that we have in the project. So we have to manage themes and styles and components behavior. So we have several guidelines for each of these behaviors. So if we want to create a specific context for the whole project, I guess it will take like a long file, with hundreds of lines and stuff. So as I saw in the presentation, like less is more, right? So I was thinking using what Eric said about index files. What if we, instead of index files, we index like contexts that we would work, or are cases of using that?
So what is an interesting part in this case for you is that you can solve it in two ways now, right? Context engineering is relevant because we are working with agents that have this exploration capability. And if you do that in two phases, you will be able to solve your problem, because then you don't need to so strategically think about where you put this enormous amount of user design standards. And what that does is basically before you do any kind of work, you use a planning phase. In the planning phase, you ask it to explore all the standards that are there, pick out the ones that are relevant for your particular case. And then when it finds the relevant ones, it can copy it into the plan or make specific references. And from there, basically, when it does the planning on the actual execution, it has all the relevant stuff in the context, but not all your coding standards. So you just use planning mode first. And after the planning mode, when you're thinking about a plan that looks good, then you move forward. And what they can also give as a very good hint is that looking at MCP servers, for example, some MCP servers are now available for Playwright, or was it Chrome or something? And what they do is that they allow you to code the whole thing in the user interface autonomously. You don't need to code it yourself and test it yourself. When it builds the feature, it will start it up. It will check if the flow looks right. It will fix it if it isn't. And therefore, it will also be able to align how it behaves and how it feels with the standards that you have put in place. It's going to be like supercharging your development there.
Okay, thank you.
Yasmin?
Hello, good morning. Can you hear me?
Yeah.
Okay. Hi, Gerard. Nice to meet you, and thank you for the presentation. It was great. So my question is, how can I decide when the context is good enough for the AI instead of adding more instructions?
Yeah, good point. This is what we're using also on a continuous basis to improve it. Basically, if you find that you cannot, how to say that, ask your AI something and it comes back and it goes somewhere wrong, then you know that there's a gap. So the ideal case is that you have your code base and your documentation and stuff so perfect that when you ask it a question, it can solve it start to finish completely autonomously without a human intervention. If there is an intervention, then you have to start to analyze it. Similar to if you have an incident in production that something happens, you would do post-mortems, some kind of analysis to figure out what went wrong, and then you fix it. So here, ask a question. If it doesn't do it autonomously end to end, you need to look into it, fix it, and then move forward.
Okay, thank you for the answer.
O próximo é Pedro, não é isso?
Isso.
A gente tem
Yeah,
mais
tudo
5
bem?
minutinhos, mas aí vamos indo, tá bom? Só para manter o horário de Gerard. Vai lá, Pedro.
Ah, tá
Maravilha.
bom.
Obrigado pela apresentação. A minha pergunta é se esse fluxo que você apresentou, como que ele se relaciona com essas ferramentas de gestão de projetos, como o Gira, Linear, de que forma que a gente pode utilizar elas para integrar todo esse fluxo?
Tem uma empresa que se chama Unblocked. Essa empresa é um SaaS e ela faz basicamente um conjunto de todas as coisas que você tem. Né? Nós estamos utilizando o Linear para poder ser o Gira, o GitHub. Então ela cria de uma forma diferente como se chama um hypergraph, que é um grafo, né? Ele disponibiliza isso como uma ferramenta pelo MCP, pelo servidor MCP para o Cloud Code Agent que você está utilizando. Então, basicamente, isso é um exemplo que você pode utilizar ainda aquelas outras ferramentas para frente. Também, do mesmo jeito, Linear e Gira, elas são feitos para uso humano, priorizar, etc., esse tipo de coisa. Eu acho que o que nós estamos começando a utilizar, ou não, nós estamos utilizando o Linear já por muito tempo. O Linear é uma ferramenta mais rápido do que Gira, em termos de recarregar a página e tudo isso. Então, isso já é um passo para uma outra realidade, onde você não necessariamente mais olha para todos os issues abertos e faz a gestão como um gerente, mas também no futuro tem grande possibilidade que você vai pedir ao AI para criar um plano para você assumindo os colaboradores dentro do projeto, os recursos, quanto tempo vai levar, tal e tal. Se ainda a gente vai continuar a escrever código. Eu acho que no futuro ninguém vai escrever mais código, não. Os engenheiros, eles vão fazer basicamente parte do gerente do projeto. Tudo vai subir o nível. O gerente do projeto não é mais gerente, ele é gerente de features, gerente do produto, por exemplo. De outra forma. Como exatamente eu não sei, mas se ninguém me escreve mais código, as pessoas elas vão fazer coisas diferentes. Olhar para a qualidade, trabalhar no ecossistema que tem, né, para produzir tudo isso. A fábrica escura, basicamente.
Maravilha, obrigado, Gerard.
Uhum.
Percebendo que o português de Gerard é muito bom, viu? Eu brinco com ele que às vezes eu acho o português dele melhor do que o inglês, viu? Ele fala holandês em primeiro lugar, depois português, depois inglês. Anderson, vai lá, amigo.
Hello, good morning. Quick question. I have seen that the AI is good to do tasks when you have a code base, when you have documentation, to do the context engineering through those files. But when I don't have it, when I need to create a new feature that is a new architecture or even a new software, what would you recommend to start with?
You're in a very good place because the performance of AI is better on code from scratch that it needs to produce instead of a legacy code that is existing. And the reason is the AI didn't write it. So if it looks different and it's a little bit like, written by humans and messy, it is going to get confused very quickly. That's why you need a little bit more documentation for those. But what we have done, we have created a data vault a number of projects over the past months. It was the CEO, who was not even a coder, who wrote in 3 weeks a proxy application for Databricks, for example. And there's also some project that I have done within a week or 2 weeks, starting completely from scratch. but then you understand the structure for it. So you do everything at once. You write the code, you write the CI, you write the infrastructure, and you write the documentation. And what I now see is that I tend to delay it because people tell me you need to deliver this feature, and I want it by tomorrow. And it is if you do that every day, then you're never going to get to your AI structure. But if you understand that if you put a little bit of investment in your knowledge engineering and in your AI infrastructure, let's say, that would allow these agents to do this more effectively, the velocity that you're getting back from that is so big that you're gonna, delay maybe by a day, but everything after that is going to be speed up by, number of hours. I've been working on things that it would take me 2 weeks, and I did it in an hour, for example. It's incredible.
Thank you.
Camille, última pergunta, viu, pessoal, por causa do tempo de Gerard.
Thank you. First of all, thank you, Gerard, for the content that you bring to us. But my question is regarding I have a design point of view, and I like that part that you mentioned about the amount of context you need to provide to AI, not too much, not too little. And talking by point of view of when you not provide, when this context, the context is not code, but is most text, or for example, via design research content. Do you think this amount of content, this guideline you mentioned, it applies to that also?
So I'm not 100% sure I fully understand, but basically there are two guidelines, right? If you see that the AI is hallucinating a lot, like it gives you answers that are coming from fantasy, you have not given enough context. If you see that the AI is getting stuck and it is going towards the wrong things, you have given too much context. And if you have a lot of information, you don't exactly know how to split this up, an AI can help with it, but you have to have some kind of, so an AI cannot do things magically. You have to always ask the right questions. So you spend time thinking, what questions should I ask to get the thing that I need? And that is, quite a difficult thing sometimes. But again, going back to planning mode, if you have a lot of information and you have a lot of stuff and it is too much to organize in a different way to go through automatically, then use planning mode. So you don't start immediately awaiting an answer or expecting an answer, but you allow it to explore the entire base. You say, this is my use case, this is what I need, find what is relevant, and then let's build a plan for the implementation or how this should be executed going forward. You do it basically in two different phases. Everyone that is now working at Data Vault, when we do a new feature, even a bug fix or anything else, we always use planning mode in the beginning, and then after the planning mode, that gives us the information that, oh, it's going to get sidetracked here, this is going to go wrong. We correct it, and then once the plan looks good, and we know, okay, this is actually has a very high chance of working out, then we execute and we build, and what you get out of it is usually converging very quickly to the end result that we need.
Thank you.
All right.
Gerard, obrigado. Massa lhe ver, amigo. Muito bom. Obrigado a todo mundo que participou, tá
Obrigado a
bom,
vocês,
pessoal?
tá?
Eu vou parar a gravação agora, tá bem? Depois a gente vai ver como é que vai fazer para disponibilizar a gravação. Para o pessoal que é interno do CESAR, acho que eles já sabem que é no Learning Rocks, e vou ver como é que faz o pessoal que é externo, tá bom?